Alright, in this video I'm going to demonstrate connecting to a shared location on the Rainmaker 3 MapR server and moving data to that system and having it replicate across its nodes. This will demonstrate, then I'll demonstrate the ability to perform geospatial functions on data sitting on that share. So currently what you see right now is a workstation up in Aberdeen, Maryland APG at the in the Parsons environment. It's a workstation that we've set up. And we're going to connect the share from the Rainmaker to this system. So I just need to enter in the path, and we're going to connect to node 2 here specifically. Okay, and click finish here, and what that's going to do is give me a direct connection to my system, add it here in my devices and drivers. So, along with my C drive, I can go hit the network drive. You can see there's already data here, some CADRG, some NIE map data, some chips. And what we're going to do right now is take some data from my desktop here and move it on over to the network share, and that'll show you a little bit about the speed here. So there was about a 3 gigabyte Mr. SID data, and you can see it's going to take about a few minutes. But while that is copying over, I will bring up the MapR homepage, and the homepage right here shows the different nodes that we're working with. Ignore the red right now. There's a couple of hard drive failures we need to go back and fix, but didn't want to take the system down. There's also here the share, so we're accessing the geo data. We've set up a mirror location, geo mirror, and so what the geo data is where I'm accessing where that share was, where I'm copying data to. That is the geo data, and the geo mirror is another location on here that it will be mirroring here. I just recently set that up, so it'll take a couple of days, but it's scheduled every hour. So in the next hour, it should start moving data over and replicating what's on the geo data. So the 200 or 300 gigs worth of data that are, 300 gigs worth of data that's on that in the geo data will be replicated to here within the next hour. We're not doing it instantaneously because the amount of data that would be there or move would kind of bog down the system. So I finished copying the data over. So now I have the data in here. I forgot to start up Socket GXP. What we're going to do next is access this Mr. SID data and create a chip from it. Hopefully that doesn't crash. Socket has been crashing on me a few times. And so here you can basically see how much space is also remaining on that network drive that you've added. You can see 1.22 terabytes are free of the 1.6. All right, so Socket's open. What we're going to do now is go to that file that we put on our share. So if we go to my PC, you can see the network location, select that. Then I put it in the testing Mr. SID. So here's your 3 gig Mr. SID, 3.5 gig Mr. SID that we're opening up. So we've opened up in Socket. You can look at header information if you like, which is all right here too, but it's going to generate us a nice little thumbnail. Right there's the thumbnail of it, and this will be the header. I believe this loads. Just takes a second. Oh, waiting for that to load. Oh, well, that went away. We'll create a chip of this image here using Socket. So kind of doing this a quick way, instead of doing a bounding box, I'm going to do it by radius. So I'm going to pick a radius of about 1000 pixels, and just click OK. Very quick way that I'm doing this. So now I'm creating a chip. I'm going to put a demo at the end of it. We're going to go back to my share drive, open up my folder, put it inside my chips. And I can select what type of file I want to save it as. I'm going to do NITF 2.1 versus a JPEG, but I'm going to come back in here and do another a JPEG as well too. A JPEG 2000. So you click save. Yes, it's saying that because it's Mr. Sid, it doesn't like that I'm saving it in a different format, but we're going to do it anyways. All right, so that was the chip. I'm trying to find the shortcut for my chip again. I seem to have forgotten where the chip button is. There it is. Okay. So we're going to kind of bring that panel. Oops. We're going to do it by radius again, but we're going to do 1000. To 1000. And we're just going to save it, but instead of NITF this time, we're going to do JPEG 2000. And put demo at the end again, so you know it's a demo. Select save, saving it to that same folder, same drive. All right, so now we've got that saved. One other thing I didn't show is you can actually interact with data and everything within the File Explorer. So here I've got my JPEG 2000, much smaller than my NITF. NITF is about 12 megabytes. This is only about 401 kilobytes. It's obviously compressed. One thing to show is this is connecting via anonymous user, so basically anyone can edit a file or create a text file on here as it creates the text file. It's going a little slow. And I can edit it in here. But what we'll be working on is some of the user permissions and restrictions for it. And as you can see, it should have saved it, and I can open it back up later. I'm going to close socket. It slows things down a little bit here. All right. So that was chipping that Mr. Sid file, which gave me a smaller NITF file. So now I'm going to open up MV here, and I'm going to open that file we just chipped. So let's go back to the testing. Mr. Sid, open up the chipped file. So and this is the NITF that I opened up. So here's this chipped file. I'm going to zoom out a little bit. Or maybe I am zoomed out all the way. Nope. There, I am zoomed out. Nope, it's going a little slow. That's all. So you can see you can interact with it in MV. You can do quite a bit of things here. What I'm going to do is do what they call a terrain 3D surface view. And basically, I don't remember which bands are the red, blue, and green, but I'm just going to randomly select it. And we're going to click OK here. So now we've got our information, our bands, it's got a little bit of information. Okay, and we're going to click OK, and we're going to make the vertical exaggeration about 20 here, so we get a little more depth to this image that it creates. It's doing an image resolution of 1024. I'm leaving everything default, so, and we'll let this run. And now you can see I kind of have a 3D view of my NIDIF image that I imported in here. Pretty cool. And I believe I can export this out as well if I wanted to. There's like a, you can save the surface picture as, you can print it. There's a few other things too in here. So just to kind of give you an example of the different things you can still do with imagery that's connected on this NFS. So that was MV. Now with MV, I can open up ArcMap. I can let's connect to that folder. Looks like I already had a connection there from previous. So we can go to that data that I imported. We can load the Mr. Sid. There's a thumbnail that was automatically created, that JPEG 2000. So this is a Mr. Sid off from the share. That's the drawing pause. There it goes. So I can zoom into the Mr. Sid just like I would on any other ArcMap. But this, just remember, this Mr. Sid is not local. This is Mr. Sid off of the share that's connected to the Rainmaker 3 MapR server. Just get in close just for purpose of demonstration. Okay. I can pull in the chip that I created. I'll just do the JPEG 2000. It's a little smaller. Yes, we know. So here's the JPEG 2000, the image chip I created. It's you can tell the quality is very different than the NIDIF that I create, or the NIDIF chip that we created, which I'll pull in right here. So we now have the NIDIF image in here. It's black and white. It's just the way it came because of the coloring, but you can see that's also here. I wanted to do a view shed. Let's bring in some other data that I have. I have some CIB data, which make it a little easier to do a view shed tool analysis. So as you can see right here, this is all on that shared drive. I basically accessed the FileGeo database, grabbed a Mosaic data set of CIB, and I can zoom into the area and we can take a look at the CIB. So it's pretty fast. It's not, you know, extremely fast, but it's not extremely slow. So now again, this workstation is sitting next to the MapR server, so that is why you'll see some performance gains. It's on the same network and in the same environment. So next thing I'll do, whoops, thanks ArcMap. Let's throw my view shed points in here. So I think I've created two points. Where are my points? We will just create some new points. This looks like a good area for view shed. So here's what we will do. Is I will start my editor. I'm going to now modify viewsheds. I'm going to remove any points that might be in this database. They're not needed for this demonstration. Try this again. Okay, there, it should clear it out. All right, next I'm going to create a new point. We're going to create the point right along one of these do it right there. Okay, and then I'm going to stop editing. So I've created a point. Should be did that disappear? Cool. Let's put this on top so we can see our points here. We'll make this point a little bigger so it's a little more obvious. And then we'll need a toolbox. And I'm going to make this real simple, so I'm going to use the CIB because my point's on the CIB. Okay, and then I'm going to use my viewshed points. And I'm going to leave everything else default. When I click OK, this should run and provide a result. Pending ArcMap does not crash. While we're waiting for that, I believe here wanted to also show that if I wanted to edit the chip's properties, I actually know this better in Socket. So let's see if we can figure it out on the fly. No, this is allowing you to just look at it. So here I can edit this file. The MV metadata can add to it. So I can change the columns, the rows, the bands, you know, whatever type I want here. I can change different spatial references. And this is just kind of the header and stuff. And then click OK, add more items to it. But because I'm not a spatial expert, I am not going to mess with that too much. That is a problem. I did forget something. I need 2 points. No, I don't want that. I want to create viewshed points. I'm going to create an observer. Right there. Save my edits. Stop editing. And come back and run this tool again. as we wait, can change any of these things, save, and it'll save it, but I don't want to mess up my image while it's being used in other things. We could put acquisition time in there. We'll say we got it the 29th of November 2012 at 1700. Three seconds, and click OK, and that modifies our header. And then I believe I can save it, or it automatically saves. Alright, let's check on this. We got another error. Fine. So I am executing my viewshed incorrectly. But you can kind of get the point of the ability to create and run different tools on files and things that might be on that share. So all right. Let's try this again. So last time it ran pretty quickly. I assume it's airing out because of that. So this is the last time. If it doesn't work, I was able to demonstrate though that you're able to run different processes on this. We can also run quite a few things we can do on here. Even on this, we can change some of the things on the imagery and save it all for chip it again. There's another NIDIF or NV file. Looks like my viewshed is failing, but you kind of get the point. It's possible. The other cool thing is you can still create a Mosaic database from data on the system. So this database is pulling, this Mosaic data set right here is pulling all the different imagery files from these folders here, from DTAD, land cover, RPF, raster products, CIB, and 4POP. So when I put this onto our ArcMap, it's pulling from these other Mosaic data sets, the CADRG, the CIB, DTAD, Natural, VU, and 4POC. And so when it loads, ignore it's giving me geographic coordinate systems because of the other thing. But as you can see, I have CIB at this level, and as I zoom out, I start to see some of the CADRG maps, and then as it continues to load, you see some natural view. And then finally, you should see more CADRG. I believe there's some on top here. Yeah, that's what we're seeing here. So there's the CADRG. And this ends my demonstration. And this is all pulling from the file share, which is Z. Whoops. And if you have any questions, please feel free to ask. Thanks.